Hello, Assalamualaikum. Boleh dengar saya, teacher? Okay. Alright, so let's begin the class. Teacher nak minta Nafis, can you please lead the prayer? Okay, good.
Bismillahirrahmanirrahim. Allahumma aftah alaina hikmataka wa anshur alaina min khazaini rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wa sallallahu ala sayidina Muhammad wa ala alihi wa sahbihi wasallam walhamdulillahi rabbil alamin.
Amin. Okay, thank you so much, Nafis. Alright, so for today's class, please keluarkan awak punya module, okay, gravitation. So we're gonna discuss the introduction part lah. Okay, especially the formulas, the relationships, okay, the theories. Alright. Oh, Mama, let me share the screen for you. Okay, boleh nampak tak? Ni. Dia punya ni. Boleh ya?
Boleh sir.
Okay, good. Okay, so untuk part ni, okay, sebabkan you pun dah belajar kan. Okay, so kita straight away proceed lah. Okay, with the questions. Okay, basically you need to understand Newton's universal law of gravitation. So dia nak tekankan bahawasanya in between two bodies, okay, example lah, okay, in this diagram. So we have moon and also earth. Okay, in between these two bodies, there are forces acting in between. Okay, the forces name is gravitation. Okay, so benda-benda macam ni lah. Okay, so a person who jumps up will return to the ground. What forces causes the person to return to the ground? Okay, anything that attracts back to the center of the earth, okay, yang is coming from the center of the earth. So that involves the gravitational force. Okay, sama juga situations, let's say dia punya clue dekat sini for questions number 2. Okay, remain in the atmosphere without escaping to outer space. Maksudnya there's something that preventing the air molecules to disperse further lah. So benda yang menarik the air molecules, okay, the force is gravitational force. Okay, same goes to here. Okay, sama referring to the diagram lah. The moon revolves around the earth without drifting away from its orbit. Kita tahu every planet, okay, moons and also the suns, okay, sun as the center lah in our theory. So earth and the moon, they are actually revolving, okay, they revolves in its orbit. So dia tak akan berlanggar because dia ada dia punya orbit, okay, dia berjalan, okay, dia revolve too in its orbit. So pulling force, okay, pulling force bukan satu objek saja yang exert, okay, there's also another force exerted by the another body, okay, that is gravitational force. So the answer is yes. Okay, now you boleh check terus lah. Okay, this one is just basic understanding. Okay, so basically what we can understand about the gravitational force, okay, yang ini saya tekankan yang nombor 5. Okay, so this is what exists in our outer space lah. We have the sun, earth kat mana kita tinggal, and also the moon. Okay, so basically these three bodies, there are three bodies. Okay, so earth dengan sun, okay, pun ada gravitational force acting in between, mesti in between. Okay, earth and the moon pun mesti ada in between. Okay, macam mana nak tahu in between? You can take a look at the arrow. Nampak ni, arrow coming from the sun, arrow coming from the earth. So dekat sini arrow indicating that two forces exerting. Macam ini exert force, ini pun exert force. So there's a acting in between lah. Okay, that's why they can remain in its orbit. Okay, and that is why the gravitational force is known as the universal force. Universal force indicating that it acts between any two bodies in the universe. Okay, apa maksud any two bodies? Tak kisahlah if it's between the earth and the sun, or the sun and the moon, okay, or earth and another planet. Okay, dia tak kisah. Mesti in between two bodies. Sekejap. Okay, ada apa-apa persoalan berkenaan dengan ni? In between two bodies? Tak ada. Okay, good. Alright, so gravitational force exists between two bodies. Okay, both bodies experience gravitational force of the same magnitude. Okay, sebabkan dia in between. So it's similar. Okay, so magnitude dia mesti sama. Alright. Okay, so let's take a look at the law of gravitation. Ni law of gravitation lah. So ni kena faham. What does it mean with the law of gravitation? Ni boleh highlight kat sini lah. Newton's universal law of gravitation. So basically Newton states two theory lah. Okay, dia ada two theory, senang kata relationships. Kita fahamkan apa maksud relationships dekat sini. So without looking at the answers yet, you should know that when we're talking about relationships, it's either you are actually trying to relate. Either these two things are directly proportional or maybe inversely proportional. Alright, so take a look at this. Okay, you have first body. Jasad satu means first body lah. Jasad dua second body. M1 indicating the mass for the first body. M not 1 kat bawah ni. Okay, jangan confuse lah. Okay, this M2 indicating the mass for the second body. Okay, there are force acting in between. Gravitation force lah in between here. Okay. So what Sir Isaac Newton's states, okay, in terms of the law for this gravitation, gravitational force is directly proportional, okay, to the product of the masses of the two bodies, that is F, okay, in the relationship M1 and M2. Meaning, okay, gravitational force depends, okay, dia bergantung kepada mass of the two bodies, but bukan satu saja punya mass, both all together. It's a product. So kena ingat when they are talking about product, so you straight away tahu it involves multiplication. That's why M1 multiply with M2. Okay, so F is directly proportional to M1 and M2. Okay, can someone tell in detail lah, explain what does it mean by directly proportional? F is the gravitational force. So macam mana nak explain lah secara kasar in relationships between the force and also the mass? Apa yang you faham berkenaan with directly proportional?
The higher the products of the two masses, the higher the gravitational force.
Yes, very good. Okay, the mass itself influence the magnitude of the force. Okay, so if the magnitude of the mass is high, okay, kalau value dia tinggi, force pun akan tinggi. Okay, good. So kalau you boleh keluarkan formula ni, you tak perlu nak hafal ayat yang panjang because you dah tahu apa yang perlu ditulis. F in proportion to M1, M2, then straight away tulislah in sentences. Okay, that's why sangat penting nak tahu macam mana nak olah formula tu. Okay, second thing that Newton states in terms of the universal law of gravitation, okay, gravitational force is inversely proportional. Just now is direct, now is inversely proportional to the square of the distance between the centers ni. Yang penting, keywords dia. Okay, kalau you take a look at the diagram, you have two bodies. Dia punya R here, starting from the center and starting from the center. This is the R. Kan kalau dalam maths kita belajar radius is only from the center to the surface kan. Jangan confuse. Here R indicating distance from the center of the first body to the center of the second body. This is R. But in terms of the relationship, F is inversely proportional, okay, to 1 over. So basically, F okay, inversely proportional to the square of the distance. So kalau dia adalah inverse, mesti 1 over. Okay, so apa yang saya highlight ni tolong states in terms of the theory lah. Kalau dia minta, okay, states the relationship under the Newton's universal law of gravitation. Kalau tak ada perkataan centers ni, you hanya jawab square of the distance of the two bodies. Tak boleh dapat markah lah because you're not clarifying that the distance is actually from the center to the center. Okay, so F inverse, okay, 1 over R squared lah sebab dia inverse, so we see 1 over R squared. Okay, explain pula what happen kalau the distance is getting further apart. What happened to the F? Let's say lah the distance increasing. So what happened to the F? Will the gravitational force increase or decrease?
Increase.
Kalau kalau distance dia makin jarak from center to center.
Decrease.
Decrease.
Yes, decrease. Okay. Sebab R dekat bawah, right? F is on top. So it's inversely proportional, which means that if this side is increasing, another side, that side lah. Okay, the opposite side is decreasing. Okay, that's the meaning lah for the inversely proportional. Okay. So boleh ingat tak relationship, these two relationships ni? Boleh ya? Okay. Saya nasihatkan hafal this only. Okay, ni maksud saya ni. Alamak, tergelap pula. Ni F, M1, M2, F, 1 over R squared. Then only you olah dia punya sentences. Okay? Alright, so settle with this page. We proceed with another page. Okay. Alright, so hi. This is how we present in terms of the formulae. Okay, so we have two theories ni. Ini adalah dua teori tadi tu lah. Those two relationship. Okay, directly proportional and inversely proportional. And if you combine these two, you will get this. Okay, products of the masses, of course, on top because it is directly proportional. Okay, the distance from center to the center of the bodies, it will be at the bottom lah, over R squared because it is inversely proportional. Okay, why the states like this? Kenapa ada pula benda ni? Here, from here it becomes here. F equals to G. What is this G? Cuba ingat balik.
Gravitational constant.
Okay, gravitational constant. Ada value ke this gravitational constant?
Ada.
Is it fixed or changing?
Fixed.
Fixed. What's the value?
6.67
Multiply?
multiplied by 10 power of negative 11.
Okay, good. So please hafal this. Okay. Because this topic is quite new, so we are not sure whether this value will be given or not. Okay, so please familiarize yourself lah. Ada certain benda kan you akan automatically hafal. Seperti contohlah speed of light. Terus tahu kan berapa speed of light, 3 times 10 power of 8 meter per second. Benda-benda macam ni. Okay. Sometimes if they ask you to state, okay, you boleh mention lah 6.67. Ni contoh dia. 6.67 multiply with 10 to the power of negative 11. But what about the unit? Meter squared, kilogram, kilogram negative squared. Okay, macam mana nak hafal benda-benda ni? Please, seboleh-bolehnya olah balik, susun balik. Okay, masuk susun balik. Imagine you are tinggalkan G ni here. So this R you gonna bring it here. Okay, R is what? Meter squared lah kan. Mass is already kilogram. Kilogram multiply with kilogram is kilogram squared. But if you bring it here, you're gonna be at the bottom there. So negative squared. Okay. F is Newton. So inilah unit for G. Sebab tu kalau you tahu SI unit, you susun je balik. Then you confirm, okay? Confirm the unit is blah 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 blah. Alright. So ingat balik lah how to do it. Okay. So ni Newton's universal law of gravitation states that ini ayat panjang lah, tapi still dia ada dua perkara yang ditekankan. There are two relationships that is being proposed. The first one, F is directly proportional to the product of the masses. And you can straight away state that it is also inversely proportional to the square of the distance between the center of the two bodies. Ini dia dah combine dah the statement. All in all, still there are two relationships proposed dalam satu ayat ni. Okay, so if you're not able to combine the sentences, terlalu panjang for you, then make it as a point. Okay, buat point yang pertama, buat point yang kedua. Okay, asalkan you state the universal law of gravitation memenuhi dua perkara ni lah. Okay, so far okay?
Okay, sir.
Okay, then straight away lengkapkan ni. Ni mestilah you tahu dah. Okay, gravitational force. Ini adalah simbol dia lah. Symbol, and what does it mean with F, M1, M2, RG. Alright, so itu sajalah. And this is the formula that we're going to use. Ini adalah formula pertama yang awak akan hafal kan. Perlu hafal dan ingat. Okay. Alright, so if they ask you in terms of questions, simple je lah. Dia bagilah ayat yang panjang-panjang kan. However, apa yang you perlu take note juga, take a look lah. First, you can extract the information, calculate the gravitational force between a durian and the earth. Dia dah bagi mass of durian, mass of the earth. So it depends on you whether you want to decide durian as the first body, earth as the second body, up to you. So in this example, they decide that the durian as the first one. So that's why they note M1 as the durian punya mass. Okay, earth as the second body. So they note earth as the M2 lah. Okay, it depends. So distance between the center of the durian and the center of the earth. Bila dia dah cakap center to center, confirm this information will give you R. Okay, so G, okay, G kalau boleh hafal, 6.67 multiply with 10 to the power of negative 11. Okay, so you just use this formula, F, G, M1, M2 over R squared. Okay, so take a look at these numbers kat sini. Apa yang kita perlu beri perhatian lebih lah when we are dealing with this type of numbers? What are the things that you can give extra cautions here? Ni nombor yang panjang-panjang ni, macam ni kita nak deal dengan dia? Perlu berhati-hati daripada segi apa ni? Yeah, very good. Awak cuba ambil kalkulator awak dan awak terus multiply without bracket. You akan dapat jawapan yang sangat-sangat berbeza. Okay, so for every substitution, let's say mass 1 punya value, mass 2 punya value, please letak, okay, letak bracket. Okay, so G, 6.67 ni, dia dah bracket kan. M1 durian punya kan, so eloknya bracket terus. Ini bracket kan. Okay, tak kisahlah you calculator jenis apa, you nak susun ke. Kalau calculator yang 570 tu dia lebih canggih kan, dia terus boleh buat pecahan dan atas tu you insert nombor, letak bracket cantik-cantik, bawah pun sama. Okay, so final answer jangan lupa mesti ada unit. If you give only the value, okay, only the magnitude lah, without indicating siapa punya magnitude tu, so you will get marks. Okay, because we assume that you don't know the identity for the force. Kita tak tahu. Kita assume tak tahu pun force tu is measured in terms of Newton. Okay, so please be extra careful lah. Okay, over here. Okay, sama juga kalau in terms of another method, they just nak cari benda lain lah. Still they use the same formula lah. Okay, F equals to G M1 M2 over R squared. Okay, but when you get this, please extract the information first. Okay, keluarkan dulu perlahan-lahan. Okay, a rocket at a launching pad experience a gravitational force. Okay, here confirm ini force lah, F. Okay, first dia dah mention lah gravitational force. Okay, and second thing is it is in Newton. So confirm this is F punya. So they are asking you what is the mass of the rocket. Okay, here they already give you the mass of the earth lah. So up to you whether you want to decide earth is M1 or M2. Okay, all in all you need to find mass. Your final answer must be for mass. That's why when you already finish substituting, so you will get the answers with unit in kilogram. Okay, macam itulah. Dia nampak complicated sikit sebab nombor dia panjang, tapi bila you write down, make sure it's systematic. Starting with stating the formula first. Lepas you dah keluarkan the information, please write down the formula. So after you write down the formula, substitute Okay, ini siapa punya F letak nilai, ni letak nilai, bla bla bla. Okay, ataupun you nak straight away susun like the symbols first. Okay, when you already start the formula, now you are looking for M2 and then you susun balik. Okay, F multiply with R square, divide with G, multiply with M1. Okay, up to you. But the subject right now is already mass. Okay, so your final answer will be in kilogram. Okay, by right, sekarang ni you sepatutnya tak ada masalah expressing your answer. Maksudnya bila you jawab, calculation tu dah kemas dah tak memeningkan dalam keadaan yang teratur. Sebab ni dah always being emphasized. Daripada dulu, nak cara jawab mesti bersistematik. Jangan cacah marba, sekejap calculate lah. Macam conteng je. No lah, tak boleh lah. Kejap nombor kat sini, kejap nombor kat sini. Walaupun bawah ruang yang sama, tapi tak teratur. So meaning you tak buat itu secara sepatutnya. Okay, tak boleh lah. Alright. Ada lagi ke yang nak baru masuk? Okay. Alright, so yang ini just activity saja. Okay. Ada any questions on this part before we proceed to the next part? Make sure you take note of the answers. Tandakan mana yang dah tu elok-elok. Tambah nota sikit, maybe dia tercicir in terms of unit ke apa ke. Okay, boleh? Can I proceed to the next page?
Boleh.
Okay, good. Thank you.
Boleh.
Alright. Okay. Ni. Okay lah, ini tadi continuations lah from the activities that if you're doing with your partner. Okay, let's say lah, secara logik lah, if they give you in between a body to a body lah. Okay, and they ask you questions like why magnitude of the gravitational force which is your F between you and your partner small. So ingatlah apa yang influence this F. Okay, so kita ada apa yang akan mempengaruhi F. Factor apa ni yang mempengaruhi our gravitational force? Apa tadi faktor dia? Ada dua. Maksudnya dua quantities yang kita perlu take note yang dia mempengaruhi this magnitude of F. Cuba ingat balik. Yeah, very good. So we have M. And second one?
The distance between the center of the two bodies.
Okay, good. So bila dia tanya macam ni, kenapa magnitude ni berubah? Kenapa magnitude berubah? Always take a look. Okay, apa yang berkait dengan dia? So F mesti berkait dengan the mass and also the R lah, distance from center to the center. So tengok, and then you can apply lah accordingly. Kalau dia tadi activity tu is in between you and your partner, which is you mass berbeza, partner you pun mass berbeza, so of course dia punya F pun akan berbeza. Macam tu. Okay, so secara tak langsung kalau kita nak fahamkan dekat sini, nampak ni dalam gambar rajah ni lah, state the effects of mass. Maksudnya ini adalah faktor yang pertama, and distance between two objects of gravitational force is the second factor lah, distance secara R tu kan. Okay, kita tengok here we have two objects here, two bodies F. Okay, ini. Okay, what we can understand from here, the larger the mass of the body, the larger the gravitational force. Kalau gambar yang ini, objek yang ni, satu pasangan, ni satu pair lah. Ni satu set. Ini bawah ni satu set. So, in terms of these two sets, yang bawah ni akan, this will have a higher F. Okay? Higher F. So in terms of drawing, how you indicate that this at the bottom the bodies ni have higher F, so you indicate by arrow here. Arrow dia lebih besar dan panjang. Okay, indicating that the F is bigger. Okay, in terms of drawing lah, kita boleh tafsirkan macam tu. Okay, take a look at this side pula. This side nak explain in terms of the distance, which is the R. Okay, you can take a look that the masses is same. Yang hijau ni sama je lah for the first set ni. Set yang atas ni same mass. Bawah pun sama, same masses. It's just that the R is berbeza lah. R ke atas ni jarak dia dari sini ke sini. Okay, F2 is a bit further. Okay, compared to the first set lah. So what we can notice that the F decreases when the distance between the two bodies increase. Okay, so F dia akan drop. So bila F tu drop in terms of how you indicating in drawing dalam daripada segi lakaran, so you boleh nampak arrow dia dekat sini shorter and lebih kecil size dia. So that's how you interpret lah dalam segi lukisan. Nak tahu how to indicate this type of information. Okay, boleh ha? So selain daripada ni, relate balik dengan formula. Okay, siapa yang directly proportional and siapa yang inversely proportional, baru you boleh dapat state these two thing. Point yang pertama and also point yang kedua. Okay, when you are able to state, relate that with the formula. Okay, next kita nak tengok formula. Okay, itu adalah basic punya. F equals to G M1 M2 over R squared. Now, kita nak tengok formula, okay, that we can apply based on different situation. Okay, based on different situation. First, take a look. Di bahasa Melayu lah, tapi you faham je lah kan. Dua jasad tergun di bumi. Maksudnya, these two bodies is at the same place lah. Okay, if it's at the same place, okay, indicating at the same place, you just straight away use this formula. F G M1 M2 over R squared. Okay, next is kita nak tengok formula what happen if it's on the surface. Bermaksud ni, here from the center, you have an object betul-betul dekat surface of the earth. Okay, bermaksud right now the R bukannya R yang kecil ni in between center to center. Your R is actually apa dekat sini? Apa maksud R besar ni? Okay, R yang radius, siapa punya radius ni? Yes, very good. Ini R besar ni adalah radius of the earth. Okay, so if the body is actually on the surface of the earth, you will use this formula. Okay, G M over R squared, which means this. Okay, so capital letter M ni mass of the earth. M ni bodies ni, yang orang kecil ni. R besar ni adalah the radius of the earth. This is the formula. Nampak sama kan? Tapi berbeza. Okay. Tapi once you understand the first concept, you can actually straight away faham lah kenapa dia macam tu. Okay, next is situation for here. Let's say you want to compare from the earth to the satellite, which means any objects lah that is way above the surface here. Okay, ini tadi earth punya radius, but right now the object is over here mah, so itu ada h, which means that there's another additional of height here. So in terms of the formula, so you can include lah height ni dalam ni. So that's why the distance right now, bahagian bawah ni kan berkenaan dengan jarak kan. So it's the radius plus with the h. Tambahan satellite ni from the surface squared. Tu maksud dia. So the R right now is actually h plus R. Macam ni tadi case dia radius tu lah adalah dia punya distance. Okay. Nampak tak macam mana nak apply on different situation? Can you see this? Macam mana nak apply? Faham kan? So saya cakap you tak perlu nak hafal pun this thing. You just understand the situations, nak guna yang mana, what type of the situation, and you understand the way, the distance right now is what type of distance. Adakah dia radius bumi sahaja ataupun dia radius bumi plus distance from the surface to the object. Okay. Alright, now take a look at the here in between the sun and also the earth. Okay, right now kalau dia sun and the earth lah. Okay, so let's say this sebenarnya sama juga konsep dia. Kalau dia ada sun and the earth, dia between two bodies, right? Two bodies. Okay, so you guna formula yang sama. Cumanya apa? Mass lah. Mass berbeza lah. Sama konsep lah. mass MB ni maksudnya mass kepada bumi ni lah. M ni mass of the sun. R still center to the center. Sebab dia still two bodies. Cumanya information yang ni adalah information yang Earth and Sun lah relate. Okay. So basically number 4 is number 1 lah. Like that. Okay, cumanya kita dah ada specific lah. We know that M1 and M2 ni apa. Like that. Okay, so yang penting you understand 3 ni cukup lah. Tenang. You already confirm this 3, so you know these 3 different situation. Okay. Alright, so kita tengok ni lah macam mana nak apply, okay, in terms of the formula. Okay, yang ini adalah information yang dalam kotak ni is actually the informations lah for the sun, man-made satellite, Earth, Moon. Okay, basically dia ada mass, okay, and distance between the Earth and the Sun, and this is the R lah. And then you have about the Earth, about the satellite, about the Moon, satellite and Earth, and about the satellite, and then Moon. Okay, biasa dibagilah. Alright. Okay, so ni kita tengok kat sini. What is the ni situation lah What is the gravitational force on the man-made satellite? Okay, jangan go for. Even though it's already indicating about the satellite, tapi dia ada satu statement yang penting dekat sini yang menyebabkan nak menentukan, okay, to confirm which formula you want to use. Okay, statement yang mana ni? What is the gravitational force on the man-made satellite before its launch? Yang mana you perlu highlight dekat sini?
Before it is launched.
Yes, very good. Please highlight in your module before it is launched. Apa maksud before? Maksudnya dia belum lagi dekat luar bumi tu, masih lagi on the surface. So in terms of the formula, if you want to apply it, you're going to use the radius of the Earth here, R. Okay. Right, M ni you tahulah mass of the Earth, M besar ni. Okay, M kecil ni is the satellite punya mass lah kat sini. Alright, and jangan lupa you do the calculation, tolong indicate the brackets. Please, masa you nak tulis kat atas tu pun please do the bracket like this. Bracket bengkok sikit lah. Susah pula nak menulisnya. Okay, please indicate the bracket. Tahulah dia separate information here. Ni G punya, mass of the Earth punya, mass of the satellite punya. Okay, alright. So next, kita compare pula the mass of the Earth, the mass of the man-made satellite, and the mass of the Sun. So based on the information given kat atas tu, we know lah, of course lah, Sun tu yang paling besar lah pasti. Okay, larger than the Earth, and Earth is larger than the satellite. Okay, so now they ask you to compare. Bila dia buat compare, you boleh buat lah which one is, you compare between two statement lah. Okay, between the Earth satellite distance and the Sun Earth distance. Okay, kita tahu kalau Earth dengan satellite, kalau tengok satellite ni, distance between the Earth and the satellite 4.22. Okay, distance between the Earth and the Sun 1.5, tapi here multiply 10 to the power of 11, ni 10 to the power of 7. So of course here, ini yang lebih distance yang lebih further. So you boleh jawab distance between the Sun Earth is longer, atau is distance is higher. Okay. Alright, so benda macam ni lah, kena take note cara nak jawab in terms of ni questions. So next, they ask you to predict the difference in the magnitude of the gravitational force and the man-made satellite and the, okay, first dia nak compare F lah, F between Earth dengan satellite, F daripada Sun dengan Earth. So which one is bigger? So apa factor dekat sini? Okay, kita buat Earth E dengan S ni, E satellite saya buat T lah, ET satellite dengan E yang the Sun. Faktor apa yang nak tentukan sama ada which one is bigger? Apa yang kita boleh tentukan kat sini? Macam mana you nak double confirm yang force tu? Predict, sebab dia suruh predict. Macam nak predict? Agak-agak gravitational force mana yang lebih besar? Sama ada Earth dengan satellite atau Earth dengan Sun?
Masses.
Yes, very good. Okay, our first strong point you can predict by referring to the product of the masses. Okay, referring to the product of the masses. Imagine you have the masses of the sun. Okay, mass of the earth. If you multiply it, you will get the number. And if you multiply mass of earth and also the satellite, the number that you're gonna get is lower than this previous one. So product of the masses lah plays an important part. Okay, hanya ada dua benda. Okay, the mass and also the distance between center to center. Okay, so take a look at these two factors lah. Okay, now questions number 4. They ask you to calculate gravitational force between the Earth and the man-made satellite. Now, this situation is indicating that the satellite is already being launched. Okay, let's say if you have an Earth over here, so your satellite is over here. So here, this Earth, here you have R, radius of the Earth, capital letter R. From the surface of the Earth to the center of the satellite, you have H. So in terms of the distance, okay, is the radius at with the h here from the surface. So that's why we use this formula lah. Okay, r plus h as the distance. Okay, so you can just substitute the information already given here from this statement ke atas ni lah. Okay, mujur dia bagi. Kalau dia tak bagi, that's why seboleh-bolehnya bila you buat banyak latihan, you akan straight away ingat dan faham lah the value by heart. Tak perlu nak rasa itu sebagai satu beban. It's by heart. Terus ingat. Okay, jelas tak? Soalan ni dah tunjukkan in several situations lah which formula to apply. Any questions on this part? Yeah. Okay, boleh. Kalau seeloknya letaklah dua sebab kita dah ada prefix kat situ kan. Okay. Kalau dia adalah actually it will give you the same ni. Kita akan ada range. You no need to worry. You will have the range. Okay. Alright. Tapi kalau you nak letak 4 pun tak ada masalah. Letak je. Okay, tapi janganlah letak yang terlalu panjang kan. Sampai 5, 6 apa yang keluar kalkulator itu you nak letak. Tak payahlah. Okay. Sebab tu kita pun dah belajar konsep. Kita bundalkan semua kan. Okay. Soalan lain? Macam mana yang masih confused nak apply situation based on situation ke the formula? Saya buat senang kan part yang ni. Okay. Baiklah, kalau dah senyap je tu, can proceed lah. Masa pun ada lagi ni, kita proceed terus. Okay, ni situations gravitational force between the earth and the sun. Ini yang mana ni? Dia guna formula yang mana ni? Ya, ni. Untuk situasi B. Force between the earth and the sun. Dia guna formula situation yang mana ni? Ya, dia mesti gunanya F equals to G M1 M2 over R squared. Cumanya, okay, dia samalah konsep tadi tu. You have two bodies. Cumanya kita dah tahu body tu apa. Ini Earth. Ini Sun. Sama je konsep. So, center Earth, center Sun. This is the distance R. Okay. Kalau dia tak mention this is Earth or this is Sun, because they already indicating in between two types of bodies. Tak kisahlah whether Earth or Sun, Earth or Moon, still you're going to use the same formula. F equals to G M1 M2 over R squared. So, this is the G. Kalau kita tengok daripada substitution value kan, G. M kat sini adalah mass of the Sun. Ni mass of the Earth. 10 power of 24, lebih kecil kan daripada 10 power of 30. Okay, so 1.5 times 10, 11. Kalau you tengok dekat sini, ini adalah distance. Nampak? Ni. Okay, nampak distance between the earth and the sun. Okay, sama je lah. Ni number one situation formula yang pertama sama je dengan situation yang kedua. Okay, cuma dia dah lebih specific mass dia tu siapa yang punya. Okay, earth and the sun. Okay, good. Apa lagi yang perlu tekankan? Soalan nombor 5 ni lebih kepada nak olah balik in terms of the formula, nak susun balik lah. Okay, let's say the gravitational force between the earth and the moon. Keluarkan balik the information so you already have the F. Okay, what is the distance between the center of the earth and the center of the moon? Dia nak suruh cari apa? Center of the earth and the center of the moon. So basically nak cari R juga. Okay. Alright. So masukkan balik F ni punya value. Ini G. Dah banyak kali buat, you akan terus hafal G2 6.67 bla 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 bla. Okay. So this is the earth. 10 power of 24 ni, ini earth punya value. 10 power of 22 ini masses of the moon. R ni kita nak cari. Okay. Tinggal kat sini. R ni tukar kalau boleh jadi R kecil je lah. Sebab kita nak seragam bahawasanya R kecil itu indicating the distance from center to center. R besar indicating the radius of the earth. Okay. So dalam calculation awak please take note of this lah. Okay. Faham So nombor 5 ni basically susun balik je. Susun balik formula. Okay. Boleh? Kan modul ni bagus sebab dia dah terus ada latihan kat situ and you terus buat lah. Okay, next dia nak ni sebenarnya dah faham dah ni. Relating the gravitational acceleration, okay, G. Ni G value kita lah. Okay, on the surface of the earth with the universal gravitational constant. Okay, kita ada berbeza lah. G ini tak sama dengan capital letter G. Okay, macam mana datang ni nak bezakan ni, apa yang beza sangat ni. Okay ni. So, kita nak tahulah apa relationship between this G acceleration ni dengan constant ni. Okay, so first kita kena derive the formula for the gravitational acceleration. G using the formula F equals to mg. Okay, ini datang pada mana ni? It's actually F equals to ma. Okay. Ni kalau saya tanya awak ni Newton's law yang keberapa ni? F equals to ma, boleh jawab tak? Siapa yang jawab tadi tu?
Second also.
Yes, very good. Okay, ada berapa total Newton's law? Okay, good. Alright. Ingat balik lah sikit-sikit kan. Bagus. Okay, so relate balik lah benda ni. Okay, kita tengok ni. Dia dah explain daripada segi sini. Okay, gravitational force causes object to fall with acceleration. Ini adalah yang G tu. Kan, acceleration tapi in terms of gravity lah, gravitational acceleration. Okay, second law of motion, F equals to mg. State je balik macam ni. Okay, gravitational force pulls object to the center of the earth. Ini force yang dah wujud yang tarik objek tu. Okay, ini the formula. Okay, so if you equate these two equation, you ambil part ini sama dengan part ini. But they are actually referring to the same F. Okay, same gravitational force. Okay, so when you equate these two, mg, gm, mm, blah blah blah, you tinggalkan G ni because M is the common factor kan. So ini dia dah mention, you can just cut it. Okay, when you just tinggalkan G ni, acceleration to gravity, you can get this gm over r squared. So ini sebenarnya kalau you tengok baik-baik, dia datang pada sini lah. And you have the G constant, M is the mass, and R squared. Okay, so kalau susah nak ingat, kalau you tak ingat nak keluarkan ini, G, acceleration due to gravity is equal to G constant multiply with the mass, okay, over R squared. You buat balik daripada awal ni. 1, 1, 1, 1 dapat ni. Tapi jarang lah dia suruh buat macam tu. Okay, so what is the relationship between the gravitational acceleration and the constant? Barulah kita confirm it is directly proportional because you are already derived in terms of the formula you get here. G ni dengan G ni sama atas. So directly proportional. Benda macam tu. Okay, factors that influence the value of the gravitational acceleration. Tengok apa yang ada dekat in terms of this final formula. You have m, the mass, and you have r, the distance. So mass of an object, distance of the object. Okay. So ini adalah extra notes. Gravitational acceleration always towards the center of the earth. Towards. Bila maksud towards, arrow tu ke dalam lah. Kalau dia suruh draw tu, awak jangan silap drawing. Ni arrow ke menghala ke bumi lah. Each planet in the universe has its own different gravitational force. Macam kita, gravitational acceleration kita is 10 meter per second squared. Okay. So like this, here. Diagram below shows the direction of the gravitational acceleration is a distance r from the center of the earth. Ini sebenarnya relate balik dengan yang tadi tu, daripada awal ni. Ni. Okay. So apa yang you faham ini je. Saya nak awak berjaya keluarkan. Sehingga dapat ini je. Baru boleh jawab hubungan dia dengan faktor apa yang influence. Okay. Alright. So ini cara nak guna in terms of formula. Okay. Sama juga situation, samalah. Kalau ada certain height, guna macam mana, R dia tu kan. Kalau dia ada surface, R dia tu here, nampak? Radius of the earth. Okay, macam tu lah. Alright, ada apa-apa persoalan ke? Macam tak confuse lagi macam nak keluarkan sehingga jadi ni, final ni. Tak ada, kalau you dah berjaya tu, you kira okay lah untuk this part. Okay, sesuai lah. Okay, done? Okay, sikit lagi. Okay, saya proceed with this. Okay, with this assumption. Okay, ini tolong fill in. Oh ya, ada lagi satu yang penting. Here, macam mana nak relatekan G ni dengan R kan? Okay, so kita tengok dekat gambaran ni, G kita kan, R ni yang ngam-ngam dekat radius surface kan. So ini kalau you double up the value, you tambah lagi value, bla 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 bla. Okay, secara logik ni lah, dia akan makin berkurang ke makin bertambah dia punya value tu in terms of gravity acceleration tu. Makin kuat ke makin perlahan?
Makin perlahan.
Ya, sebab apa? Dia dah away from the center kan, secara logik ni kan. Sebab gravitational force always towards the center kan. Okay, so macam mana nak buktikan? You boleh masukkan lah in terms of this value. Nampak ni? 2 times, 2 kali ganda, 2R, 3R, okay, 4R. And here dah memang terbukti bahawasanya the value is decreasing. Okay, only at, which is the largest is at the center. At the center pula, at the surface R, radius of the earth. Okay, so from this value that you have already calculated, so you can get in terms of graph, it's like this. If you were to plot G against the R, kan, which is the R is R, 2R, 3R, 4R, 5R, 6R. Okay, first dia akan macam nak naik because at R is the highest peak point. 10, ada almost dekat 10 sebab it's actually 9.8 kan. Almost lah dekat 10. So secara roughly dia plot here. And after that dia akan drop. Pembuktian dia dekat sini. This is how you prove it. You get this. Nampak tak relationship ni? Shape ni membuktikan yang ini. Okay? Alright. So jelas So kalau soalan seterusnya dia boleh tanya macam ni je lah. How does the value of the gravitational acceleration change? Kalau R tu lesser than the R, so dia directly proportional. Tapi kalau dia dah lebih daripada R ni, lebih daripada radius of the Earth ni, kan makin tinggi 2R, 3R, 4R, 5R, dia dah jadi inversely proportional. Here, the shape of the graph here. Part yang drop kat sini. Okay. Alright, so ini adalah dia punya calculation. Okay, so sehingga ini agak-agak boleh terus ingat dan faham tak information ni? Sebab lepas ni you akan masuk lebih in depth lebih topik yang lebih sukar lah lepas ni. Boleh?
InsyaAllah.
Okay, good. Okay, so we stop here lah. Okay, so next, yang ini you boleh ini macam modul ni, mana boleh buat boleh buat lah. Okay, mana yang partner tu tak payah buat. Okay, so saya just nak tekankan for next part saya akan terus mengajar. So ingatkan saya kalau saya terlupa ke apa ke, next part kita akan terus belajar here centripetal force. Okay, centripetal force. Alright. Okay, ada apa-apa persoalan before we end our class? Okay, tak ada lah tu saya assume. Alright, so masa pun dah almost done. Okay, so any questions please ask lah dalam group. Kalau teacher tak aware ke, tolong PM ke, sebab kadang-kadang tak perasan memang banyak kan noti masuk kan. Okay, so to end our class today, teacher nak minta Ryan Aimah lah. Can you please lead the prayer? Ryan?
Teacher.
Okay, good.
Kenapa je?
Kenapa? Apa yang saya minta tadi?
Saya baru balik daripada toilet. So teacher panggil nama saya.
Oi. Sangat tepat situasi tu. Someone tolong explain dekat kawan awak ni apa yang saya perlukan daripada kawan awak ni, Ryan ni.
Baca doa je.
Baca doa Ryan.
Okay. Bismillahirrahmanirrahim. Jangan doa dia. Bismillahirrahmanirrahim. Wal as innal insana lafi khusr illa alladhina amanu wa amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr.
Amin. Okay, thank you so much for Dilah 2021. Okay, any questions please PM me. Alright, email you. Thank you.
Thank you, teacher.
Okay.
Teacher.
Alright,
Teacher.
okay.